Hello students, welcome to the fourth lecture on the lecture series on relationship between number. So in this lecture, what we will be covering is, we will covering the types of questions or problems on relationship between numbers that are being asked on various competitive exams. Okay, so let's explore. So what we can see that there are actually 13 types of questions that are actually being asked on this topic. Okay. So the first type of questions are prime numbers and composite numbers. That is, they involve prime numbers or composite numbers. They'll ask you a number and ask whether the number is prime or not, or they'll ask whether the number is prime number or is composite number or is actually one. Okay, you know that one is neither prime nor composite. Okay. The second type of question will be on factors and multiples. Okay, whether the number of factors of 12 is 3 or 4. Okay, or 3 is a factor of 12 or not, or whether 29 is a multiple of 12 or not. This kind of questions. Okay, whether number is a multiple of another number or not. Okay, and divisibility rule, we have already learned divisibility rule up to 19. Okay, so that kind of questions are also being asked there. Okay, so prime numbers, composite numbers, factors and multiples, divisibility rules, even and odd numbers, whether number is even or odd. Okay, so LCM HCF questions, like lowest common multiple and highest common factor, that full form, and sequences and patterns, sum of consecutive numbers. Okay, we learned three formulas: Sn square, Snq, Snq. Okay, problems based on this, and prime factorization and squares, cubes and roots. Okay, so let's explore each topic in detail. And there are also the 10th kind is number series and 11th kind is number system conversions. Okay, and the 12th kind of problem is on number comparisons. Okay, and the 13th one is divisors and remainders. Okay, so let's explore the one. So the first one is prime numbers and composite numbers. Okay, so identifying prime numbers and composite numbers and finding the nth prime number or the next prime number in a series. What we are asked here is to identify whether the numbers 7, 12 and 17 are prime or composite. Okay, so we all know that for 7 it has only two divisors, that is 1 and 7 itself. Okay, so all the two criteria are met. So this implies that 7 is prime. For 12, what we have is, we have divisors as 1, 2, 3, 4, 6 and 12. Although 1 and 12 also divide 12, but there are other numbers, that is 2, 3, 4, 6. Okay, that divide 12. So this is why this is composite. So for 17, okay, we know that only 1 and 17 are the numbers that actually divide 17. Okay, so the two criteria are met, as there are no other numbers that actually divide 17. Okay, excluding 1 and 17. So 17 is prime. So the answer will be, this will be prime, this is composite, this is prime. Okay. So what we did was first checked whether 7 has other divisors, but no, it has only two divisors. Okay, so 7 is a prime number. Okay, 12 has more than two divisors, that is 2, 3 and 4 and 6. These are extra divisors. Okay, that is why 12 is a composite number. And then for step 3, 17 has only two divisors, that is 1 and 17. So 17 is a prime number. Okay, so the second kind was on factors and multiples. So finding factors and multiples of a given number. It will be given a number to you and you need to find the factors and multiples of that number. Okay, determining common factors and common multiples of two or more numbers. So let's see an example. So the problem tells us that find all the factors and multiples of 20. So let's first find out the factors of 20, the numbers that actually divide 20 and leave a remainder 0. Okay, so 1, 2, not 3, 4, 5, okay, 10 and 20 itself. So these are factors. Okay. So let's find out the multiples of 20. So what we do is multiply 1 with it. Okay. So 20 into 1, 20 into 2, 20 into 3. And the list goes on. Okay. So what it will become eventually is 20, 40, 60 and so on. Okay. So here is the answer, right? These are the only factors and the multiple series is something like this. Okay. So the third kind of question is on divisibility rules. So applying divisibility rules to check if whether a number is actually divisible by another number. Okay. So let's see an example and we'll get it in detail. So determine whether 5, 4, 6 is divisible by 3 or not. Okay. So what we need to check is 5, 4, 6. So what we can do is we will use that rule. Okay. For 3. That is we add up the digits. That is 5 plus 4 plus 6. Then what we got is a digit number. So 5 plus 4 is equal to 9. Then plus 6 is equal to what? 15. Okay. So is 15 divisible by 3? Yes. As 3 into 5 is actually 15. Okay. So yeah, we got it right. So 5, 4, 6 is divisible by 3. Just like that, we have divisibility for each number, whether this is divisible by 2 or not, since the last digit is 2. So yes, divisible by 2. Whether this is divisible by 5 or not, check the last digit. It is neither 0 nor 5. Okay, so not divisible by 5. Is it divisible by 10? Since the last digit is not 0. Not divisible by 10. Is it divisible by 9? Okay. Let's add up the numbers. That is 15. Okay. Is 15 divisible by 9? So, add not divisible by 9. Okay. So, let's check further. So, okay. This is what we got 15 and this is divisible by 3 for 3. So that is why the whole number 546 is actually divisible by 3. And we also checked for other numbers like 9, 0, 5, 10. Okay. So we can rewatch the previous video and get a gist of all the rules up to number 19. Okay. And we can test it here or with any number. Okay, so the fourth type of question is on even and odd numbers, identifying even or odd numbers in a given series or sequence. Okay, performing operations on even and odd numbers. So let's take an example so that we get a better gist at it. Okay, so identify all the even numbers between 20 to 40. Okay, so between we have what we have is 20 to 40. So after 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and then hooray, we got 40. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 even numbers in between 20 and 40. Excluding these. Okay. So here we go. 22, 24, 26, 28, 30, 32, 34, 36, 38. Okay. These are the even numbers in between these 20 and 20 and 40. So the fifth kind of question will be based on LCM and HCF. We already know how to evaluate LCM of two numbers and HCF of two numbers. Okay. Two or more numbers. Okay. So let's see an example so that we could better understand it. So find the LCM and HCF of 15. Okay, let's find out first LCM. Okay, so in order to find the LCM, what we need to do? We need to remember the full form of it. So this was lowest common multiple. Okay, so there are three parts: multiple part, common part, and lowest part. And we start from the end. That is, first we evaluate the multiples. So let's first evaluate the multiples of 15. So it will be equal to 15, 30, 45, 60, 75, 90, okay, 105, 120, and so on. Okay, and for 20 it will be equal to 20, 40, 60, 80, 100, and so on. Okay, so what we need to do is we found out the multiples. That is, one sequence is here and another sequence is here. Okay, then we need to find the common ones. Okay, so common ones is 20, no, not 20. The common one, first common one will be 60. Okay, you can see here. And the second common one will be, I guess, 120. Okay, 120 will be second common one. So what is the lowest between these? 60 is less than 120, right? So LCM of what, 15 and 20 is actually equal to 60. So we got the first answer. So let's find out the HCF. So this is highest common factor. Okay, again, what we do is we start from the end. This is the first thing that we will start. Okay, first we get the sequence of factors, that is of 15 and of 20, right? So for 15 it is 1, 3, 5 and 15 itself, and for 20 it is 1, 2, 4, 5, 10 and 20. Okay, so what you can see common down here is 1. Okay, you can see 1, and what else? You can see 5. Okay, and nothing else is in common. So what is the highest one then? First you saw the sequence of factors. Okay, we got the sequence of factors, then we found out what are commons. Okay, then we need to find the highest. So only 1 and 5 are there. And what is the relationship between these two? 1 is less than 5. So what is the highest common factor? It is 5. So HCF of 15 and 20 is nothing but 5. Okay, this is the final answer. Okay, this one here is done by the prime factorization method. Also we can use the prime factorization method. So what we can do in the prime factorization method is we factorize 15 in prime. That is 15 is equal to what? 3 power 1 and 5 power 1. Then prime factorization of 20, 2 power 2 into 5 power 1. Then what we do is, to find the LCM, what we take is, we take the highest power of each primes in between these two and multiply them. So the highest power of 3 in between 2 is 3 power 1. And the highest power of 5 in between these two is 1. So we multiply 5 power 1 with 3 power 1. And the highest power of 2 is 2. So we multiply these things, okay? And we get 60. Okay, to find the HCF, so HCF of 15 and 20 is equal to 5 power 1. That is equal to 5. So for that, what we need to do is we find the common primes first. That is 5 and 5 here. Okay, then what we need to do is we take the maximum power of 5. So minimum power of 5. That is the common prime in between these two and the minimum prime. Okay, so this was 5 power 1. So that is equal to 5. Okay, we have got it 5, HCF is equal to 5 and LCM is equal to 60. So the sixth kind of question that is being asked is about sequence and patterns. So what it asks us is to identify arithmetic, geometric or harmonic progressions, okay, sequences, and find missing numbers in a given series or patterns. So here what we are asked is identify the missing number in the series 2, 4, 8, 16 and then. Okay, so the kind of relationship between first two, let's see. So 2 plus 2 is equal to 4. Okay, and 2 into 2 is equal to 4. 2 power 2 is equal to 4. Then we need to check for these two. Okay, so 4 plus 4 is equal to 8, and 4 into 2 is equal to also 8. Okay, and okay, only these two are valid. So we can say that since 4 power 2 is not equal to 8, so this thing can be eliminated. So the pattern doesn't continue like this. Okay, this is wrong, this is wrong. Okay, so in between these two, there is only one pattern that will continue. Okay, so let's see the third pair, that is 8 and 16. Okay, for 8 and 16, how we can get 16 from 8? So 8 plus 8 is equal to 16, or 8 into 2 is equal to 16. So okay, this is nothing but 2 into 2, and this is nothing but 4 into 2. So the pattern is something like this. Okay, so an is equal to an minus 1 into 2. Okay, where n minus 1 is greater than equal to 2. Okay, so we have a sequence a1, a2, a3, and so on. And what a2 is equal to a1 into 2, and a3 is equal to a2 into 2. Okay, so an is nothing but is equal to an minus 1 into 2. So what will be the last term? So in between these two, the relationship will be, if this is x, so x is equal to 16 into 2, that is equal to 32. So x is nothing but 32. So this is the answer. Okay, so the pattern is doubling the previous number in the series. So 2 into 2 is equal to 4. Okay, this is what we have got. So 32 into 2 is equal to 64. So the missing number is 32. Here the missing number is 32, and the next number will be 64. Okay, and the next number will be 64. So the seventh kind of question that is being asked on relationship between number is on sum of consecutive numbers. So we have previously learned the three formulas, right? That is Sn is equal to n into n plus 1 by 2, and Sn square is equal to n into n plus 1 into 2n plus 1 whole by 6, and Snq is equal to Sn square. Okay, that is actually equal to n into n plus 1 whole by 2 whole square. Okay, these three formula that I already told you that are very crucial. Okay, they will be helpful to you. Okay, otherwise you will do a hectic job of individually adding up the numbers and the cubes and the squares, and that is really not the way to do it. Okay, so just remember these formulas. Okay, this formula, this formula, this formula. Let's try to use this formula in the next question. Okay, so what we are asked is find the sum of the first 10 natural numbers. Okay, so you have 1, 2, 3, 4, and so on up to 9, and then 10. Okay, so what it asks us is S10. So what is S10? So S10 is nothing but 1 plus 2 plus 3 plus 4 plus 5 plus so on up to 9 plus 10. Okay, so this is what we are asked to calculate. So imagine you are calculating these numbers up to 10. It is not a very big job. So if I ask you S100, okay, how will you evaluate? Okay, so we'll use that formula. So for now, let's use that formula and verify it. Okay, so for up to 10, what we can see is S10 is equal to 10 into 10 plus 1 whole by 2, as Sn is equal to n into n plus 1 whole by 2. Okay, so this is equal to 11 into 10 by 2, that is 11 into 5, so that is nothing but 55 here. Okay, so Sn is equal to n into n plus 1 by 2. So if I need to evaluate S100, what it will be? 100 into 101 whole by 2, that is equal to 101 into 50. Okay, that will be the answer. Let's go forward to the next question. Let's check its solution. Okay, So using the formula Sn is equal to n into n plus 1 by 2, we evaluated this answer. Okay, so let's jump into the next kind of question that is asked, that is on prime factorization. Okay, expressing a number as a product of its prime factors. Okay, so let's see a question to get a better gist. So express 36 as a product of its prime factors. Okay, so the number we are given is 36. First we need to check for its factors. Okay, so for its factors, what we know is it is divisible by 1, 2, 3, 6. Okay, and then 9, and then what I guess is 12 and 18. Okay, then what we are left with is 36 only itself. Okay, so these are the factors. Among these, what are the prime factors? So the prime factors are only 3 and 2. Is there any other prime factor? No, this is not prime. Composite, 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 and this is neither prime nor composite. Okay, so the only 2 prime factors are 2 and 3. So what we do first is, let's say 2 into 3. Okay, we have a whole in its powers. Okay, here we have 2 wholes, that is equal to 36. So 2 power 1 into 3 power 1, is it 36? No, this is equal to 6. So it is not 1. Okay, we need to increase it by another number. So 2 power 2 into 3 power 1, is it? So 2 power 2 is equal to 4 into 3 is equal to 12. We reached here, but not 36. Okay, so this is at least not 1. Okay, so then what we do is we change it to 2. So this is 9 and this is 4. Is it 36? Yes, it is. So the final power of 2 and 3 will be 2. So this is how we can evaluate it. So 2 power 2 into 3 power 2. So this is the final answer. Okay, this is how we can evaluate the prime factorization of 36. Okay, so you can see it here. This is the answer. So the ninth kind of question will be on squares, cubes, and roots. Okay, calculating the squares, cubes, and square roots of numbers. So it asked us to calculate the square root of 144. So let's see how we can find out the square root of 144. Okay, so what we can do here is 144. Okay, so for 1, what we have is 1, right? So 1, 1, 1, and what we do is, okay, this is 0, and then what we have is 4, 4, right? And then what we have here is plus 1, right? So this is equal to 2, and we need to put a number here. Okay, so 2 into 2 22 multiplied by 2 is actually equal to 44. Okay, that is equal to 0. Okay, and here 2. So this implies that 12 is the square. 144 is the square of 12. So 12 square is equal to 144. Okay, so this implies that positive square root of 144 is equal to 12. Okay, this is the answer. So the 10th kind of question is on number series problem. Okay, identifying the pattern in a given number series and finding the missing term. Okay, missing term problem. So what we are asked here is identifying the pattern and find the missing term in the series. Okay, so we are given a series or sequence of numbers 3, 6, 9, 12, 18. Okay, so let's find out the relation among these first. So let's find out the pattern among this. So let's take the first 2 digits, that 3 and 6. So how we can reach at 6? Plus 3 is equal to 6 and 3 into 2 is equal to 6. Okay, and the same thing. So from 6 to 9, how we can reach there? Plus 3. Okay, and okay, and then from 9 to 12, how? 9 to 12 plus 3 is equal to 12. So we have got the pattern. Okay, so basically an is equal to 3 plus an minus 1. Okay, n minus 1 is greater than equal to 2. Okay, so the first term is a1, then a2, then a3, and so on, an minus 1, an, and so on. Okay, so the general term here is an, and an is equal to, and we got the general formula for it. So what will be the next term? It will be 15, as 12 plus 3, 15, and 15 plus 3 is equal to 18. So the pattern is verified in this step. Okay, so 15 will be the final answer. Okay, here you can see the pattern. Okay, and 12 plus 3 is equal to 15, 15 plus 3 is equal to 18, so the missing number is nothing but 15. Okay, so let's jump into the 11th kind of question, that is number system conversions. Okay, converting numbers from one base system, binary, octal, and hexadecimal, to another. So convert the binary number 1101. So the given number is, binary number is 1101 to decimal. Okay, so what we need to do is, in binary, 1101 in binary is equal to 1 into 2 power q plus 1 into 2 square plus 0 into 2 power 1 plus 1 into 2 power 0, that is equal to 13 in decimal system. Okay, so the 12th kind of question are on number comparisons. So comparing numbers using inequality signs, that is less than or greater than or equal to. Okay, two numbers can only have one relation among these. Two numbers can never have any two or all the three relationship between them. Okay, if we have a number, say x and y, they are either one, x is less than y, x is greater than y, or x is equal to y, but any two conditions can't come at once for any two different numbers. Okay, so solving problems involving number comparisons. So let's see an example so that we can get a better grip on it. So compare 85 and 99. We know that 85 plus 14 is equal to 89. So 99 is greater than 85. Okay, so this is the comparison. Here we have got the final answer. So the 13th kind of question is on divisors and remainders. Okay, so finding divisors of a number and their sum or product. So let's see an example. So it asks us to find all the divisors of 36. Okay, what numbers can divide 36 and give a remainder 0? So basically it asks us to find the factors of 36. So let's find out. So you can see here that 1 is a factor or divisor, 2, 3, 4, 6, 9, 12, 18 and 36, as they leave only 0 remainder behind them. Okay, whenever we divide 36 with any of these numbers, what we are left with is 0 as remainder. Okay, that is why these are the divisors of 36. Okay, that's all for now. Thank you.